Proportional Relationships, Lesson 6 Notes. The review. The review is an assignment called Proportional Relationships Notes Review. Please find the assignment in Schoology, upload it to Notability, complete the review using Notability, and then resubmit it to Schoology. If you haven't done this already, again, just find it in Schoology, upload it to Notability, and then resubmit it. Okay, it's better to do it that way because the actual assignment is just the review and not the rest of the notes. All right, this lesson is on proportional relationships. Take a moment, pause your video, and get the definition for ratio, rate, unit rate, and proportion written down. Please make sure you're writing small and neat because we will be writing stuff in between each of these definitions. Okay, a ratio is the comparison of two quantities by division. It has the same units. So both quantities are dealing in feet, or both quantities are dealing in minutes, and so forth. All right, there's 3 ways to write a ratio. You should have already learned this. All right, one way to write a ratio, well, if we were in school, I would have used the example of boys to girls. I would find the ratio of boys to girls in the classroom. And the first way we would write it is using the word to. Please write that down. So one way to write a ratio is boys to girls using the word to. Another way to do it is to replace the word to with a colon. So that would be boys to girls using a colon. But the way that we will do it the most, especially in math, is to write it as a fraction to show division. Since I'm doing the comparison of boys to girls, boys is mentioned first, so it goes in the numerator. Girls is mentioned second, so that goes in the denominator. All right, so let's find some examples of ratios. Remember, it has to be the same units. Now, yes, boys and girls are not the same, but they're both human. They're both people. So it is, in the end, the same unit. All right, some other examples. We might want to compare blue M&Ms to red M&Ms. Or maybe if we're dealing with a sport, wins to losses. Both of those would be dealing in games. How many games you won, how many games you lost. For the third one, I had each class come up with an example of their own. So some examples I got were gobblers to hens, which is appropriate being close to Thanksgiving. So gobblers to hens, both dealing with turkeys. I had fly fishing to deep sea fishing. Bucks to does, again appropriate for the fall and hunting season. Another one that I liked was Crocs to Vans, both types of shoes. That kind of sparked a Nike to Adidas conversation. And then there were a couple others, but the one that I'm going to come up with, since it's most appropriate for me, is iced tea to soda. Or pop, as some of you would say. All right, so iced tea to soda. Okay, so again, that is a ratio. We're comparing two quantities that are of the same unit. Iced tea and soda are both drinks. Now, a rate is a fixed ratio between two quantities with different units, like miles and hours, feet and seconds, revolutions and minutes. All right, so I'm going to give you 3 examples of rates. Okay, the first one would be 180 miles in 3 hours. So I traveled 180 miles in 3 hours would be a rate. Another one would be 12,000 revolutions in 4 minutes. A revolution is like one full rotation, and I'll talk more about that in a moment. But 12,000 revolutions in 4 minutes. Another one would be 10,560 feet in 4,224 seconds. These are all rates. It's a ratio of two quantities with different units. But a lot of times when we're dealing with rates, we want the unit rate. In other words, we want it to be a rate per one given unit. The number on the bottom needs to be a 1. Well, how do I go from a rate to a unit rate? I use division. So again, to go from a rate to a unit rate, you divide. Okay, so if I take 180 and I divide it by 3, so I'm going to take this right here, 180 divided by 3, I get 60. So that means that 180 miles in 3 hours is the same as 60 miles in 1 hour. But for most of you, you should know that we don't actually say 60 miles in 1 hour. What do we say instead? We say 60 miles per hour. So the rate was 180 miles in 3 hours, but the unit rate is 60 miles per hour because that's 60 miles per one given hour. All right, revolutions. In a car, you will see this gauge in your car. It might look different, obviously, in different vehicles, but this shows your RPMs. And again, that's our revolutions per minute. So it's how many revolutions per 1 minute. In an engine, it's how many times the engine's crankshaft makes a full rotation per minute. All right, now, here's the key. Do you see what I boxed there in the middle? This 1 right here isn't 1 revolution per minute. It's actually 1,000 revolutions per minute. This would be 2,000 revolutions per minute, and so forth. Okay, so if I had 12,000 revolutions in 4 minutes, that is the same as 3,000 revolutions per 1 minute, or in other words, 3,000 RPMs. And for the last one, you might drop something and you record how far it falls and how long it takes it to fall. And if that's the case, that would be 2.5 feet per second. Now, I've had people put that in the calculator and they'll tell me it's 5/2. And if you think about that, 5/2 means that there is a 2 in the denominator. And for unit rates, it has to be 1 in the denominator. Okay, it needs to be a 1. So that is why we put the 5/2 to a decimal, and it would be 2.5 feet per 1 second. All right, so this line, that line means per. That line right there means per. Write that down. All right. If you have any questions on ratios, rates, and unit rates, please let me know. I do want to tell you one thing before I end the video. Rates to unit rates is what we're going to use a lot in this lesson. We're going to, in example number 1, we're going to find the rate, we're going to divide, and then we're going to find the unit rate. In problem 3, we're going to set up a rate, we're going to divide to find the unit rate. In example 4, we're going to find a rate and divide to find the unit rate. We'll do the same thing in example 5 and the same thing in example 6. So it's very important that you understand that how to find a rate and then divide it to find the unit rate. Again, if you have any questions on ratio, rate, or unit rate, please let me know.